Hi, hello everybody. So this is the video where I'm going to show you how to add and subtract rational expressions. Now I've decided to break the video into two parts. And the reason for that is there are two types of additions and subtractions dealing with rational expressions that may come up. One is where the denominators are the same. This is what I call here part A. And the next video, I'm going to show you where the rational expressions have to be added or subtracted, but the denominators are different. So we'll focus first on the denominator being the same for now. In the next video, we'll do the other case. In whatever case you have, and you can read this, once you stop the video, but in whatever case you have, the goal is to always make sure that your denominators are the same so that you can perform the addition or subtraction. In the case where the denominators are already the same to begin with, like in these two cases, the problem becomes a lot easier because I don't have to do the first part of the conversion to make them the same. So this is a lot easier to begin with. So this is case one, denominators being the same. So let's do this problem first, and then I'll show you the other technique. So here I already copied the problem, and I have a procedure to add these two rational expressions. The denominators are already the same. When that's the case, I am going to combine the numerator. In this case, I'm going to add the two numerators, and I'm going to leave it over the same denominator. So this is pretty much like adding fractions. So imagine that you have something like this. Both denominators are already the same. My computation is on the numerator. At this point, I would have to simplify or divide the fraction, which in this case, again, I'm going to divide both numbers by 3. So 3 goes into 3 once, goes into 12 4 times. So the final answer is 4/x. Okay, this is all we have to do in a situation like this. So denominator is the same, keep the denominators the same, do the operation on the numerator, and at the end, simplify. All right, so let's take a look at the second example. All right, so here's the second example, and notice again, both denominators are already the same, which makes our jobs a little bit easier. So we notice that they are the same. When they are the same, all we do is we combine both fractions under the same denominator. And in this case, I'm going to keep the first fraction here. And notice this minus is in front of everything. So it's like I have an invisible 1. This invisible 1 multiplies this, multiplies that. So I have minus 2x, minus 1 times minus 1, plus 1. Notice that we're not going to touch the denominator yet. X squared, combine like terms now, 6x minus 2x plus 4x, 2 plus 1, 3. So we make sure to see if we didn't make any mistakes. X squared plus 4 plus 3. So at this point, I have to ask myself, can I factor the numerator? Can I factor the denominator? So I'm going to try doing that. Okay, in the first case, and I'm going to do it here on the corner because this is a topic that we've covered in chapter 5. So we are a little bit fluent in factoring techniques. So this is a trinomial with leading coefficient 1. I need to find two numbers whose product is 3, whose sum is 4. And I think the pair that I'm looking for is 1 and 3. So I am going to go immediately and factor the trinomial using these two numbers, x plus 1, x plus 3. I'm going to do the same thing with the denominator. I need two numbers whose product is -6, whose sum is +1, right? There is an invisible coefficient of 1 in front of the x. So in here, I can have a pair of 1 and 6, or 2 and 3. And the only way to get a sum of 1 is if I use the pair 2, 3, but the 2 has to be negative. So now I have -2 plus 3 is 1. -2 times 3 is -6. So the pair I'm looking for is -3 and 2. So I'm going to use it to create the product right here. They are fully factored now. All I have to do is to simplify, as we did before, common factors on opposite sides of the fraction, and I am left with the final answer, x plus 1 over x minus 2. And notice that these two x's do not cancel. So don't cancel them. This is your final solution for this problem. Okay, so when we have identical denominators to begin with, our job is very similar. It's very simple. We just do the operation on the numerator. We simplify the numerator. We factor if possible. And if possible, identical factors will cancel on opposite sides of the fraction, and we would be done with our answer. So that's all we have to do for identical denominators.